In this video, we're going to take a look at the conic section of hyperbolas. Now, this is a part of a series where we talk about a lot of different conic sections like circles, ellipses, parabolas, hyperbolas. All of the conic sections are formed by the intersecting of a cone and a plane. In particular, hyperbolas are formed when that plane passes through both sides of the cone. So we're going to get two separate pieces that form a single hyperbola. Now, if we're in the XY axis and we center the hyperbola at the origin, then we can write a hyperbola one of two ways. Either x squared over a squared minus y squared over b squared is equal to 1, or y squared over a squared minus x squared over b squared is equal to 1. When we are dealing with the hyperbola whose positive part is x squared over a squared, and whose negative part is the y squared over b squared, then our hyperbola points left and right. I call this graph pointing left and right. When we have y squared over a squared as the positive and x squared over b squared as the negative, then our hyperbola points up and down. Now, regardless of which version of hyperbola we have, there are some features of hyperbolas that are common to both equations. We have two types of axes. One is called the transverse axis, and the other is called the conjugate axis. The transverse axis is length 2a, and the vertices are at the end of the transverse axis. The conjugate axis is length 2b, and there are no points at the end of the conjugate axis. I should say no points on the hyperbola at the end of the conjugate axis. Now, another interesting feature of hyperbolas is that they have asymptotes. We have asymptotes of y equals plus or minus b over a times x, or y equals plus or minus a over b times x. That's going to depend on what form of the hyperbola that we have. If the b part is underneath the y, then the slopes of the hyperbolas will be b over a and negative b over a. If the b part is underneath the x, then the slopes of the asymptotes for these hyperbolas will be a over b. Think of the slope being change in y over change in x, and so we do the number underneath the y over the number underneath the x. And we'll take the positive and negative versions of those. By the way, as we're going through this, the transverse axis is going to link up the two vertices of the hyperbola. So when you point right and left, the transverse axis is going to be horizontal. When we're pointing up and down, the transverse axis is going to be vertical. And the conjugate axis is going to be the opposite, but it's not going to touch the hyperbola. So transverse axis transverses from one vertex to the other. Notice that when the x is the positive part, the transverse axis is moving in the x direction. When the y is the positive part, the transverse axis is moving in the y direction. Now there's going to be foci that I call being on the interior portions of these two parts of the hyperbola. So there's going to be two foci. Each focus is going to be on the interior of one of the parts of the hyperbola. Since they're on the interior parts of the hyperbola, they're just beyond the transverse axis ends. So we're moving in the transverse direction, and they're going to be C units from the center. Now, here's where we have to be very careful, because with the ellipse, C squared was A squared minus B squared, but with a hyperbola, C squared is equal to A squared plus B squared. So the two foci for the hyperbola are C units away from the center, where C squared is equal to A squared plus B squared. Again, A squared plus B squared for a hyperbola. The eccentricity of the hyperbola is going to be C over A, just like it was with the ellipse. Now, mostly we deal with the algebraic properties and the algebraic features of the hyperbola, but a hyperbola is a really interesting geometric shape as well. Technically, a hyperbola is the set of all points where the distance from point to the first focus subtracted from the distance from point to the second focus is constant in absolute value. So let's take a look at what that means. So here I have a hyperbola. This one in particular is y squared over 25 minus x squared over 16 is equal to 1. And notice that because the y is positive, it's pointing up and down. So pointing in the y direction. So I've calculated the two foci. They're about at 0.6.40 and 0, negative 6.40. And then you can take any point on this parabola. I have a special formula for that. And as we move that point around, the two distances from focus to the point and from other focus to the point are going to vary. So for instance, in this case, the distance from the point to the first focus is 12.67, and the distance from the point to the second focus is 22.67. Notice if you subtract those two numbers, you get a negative 10, or if you subtract it in the other way, you'd get a positive 10. Well, what if we change our point? Now the distance from the point to the first focus is 2.758, and the distance from the point to the second focus is 12.758. Once again, subtracting them, I get a negative 10. And I can do that regardless of what side we're on. If I'm on the bottom half of the parabola, or excuse me, the hyperbola, bottom half of the hyperbola, here's another point. And if I subtract 20.38669, whatever, and minus 10.38669, whatever, notice you get a 10. So regardless of where the point is, when you subtract those two distances, you're always either getting a 10 or a negative 10. And again, that means that hyperbolas have some nice features. Now, I want to point something out, that when you look at hyperbolas right where they curve, they kind of look like a parabola shape. Right where they curve. But as you scroll further and further out, you see that the ends of these hyperbolas are not parabolic. The ends of these hyperbolas look like lines going in all of these directions. And that's where we end up with those asymptotes, okay? And the slope of the asymptotes here would be 5/4 because I have a 25 underneath my y squared and a 16 underneath my x squared. And if I highlight those two lines, y equals 5/4 x and y equals -5/4 x, you can see that those are the two lines that our hyperbola approaches as we move further and further out in all four directions. So while it looks kind of parabolic shape right at the turn, that's just because it's turning there. And then as you go further and further out, it looks more like a line in each of these directions. Because of that, the hyperbola has a lot of nice other geometric features that we're not going to cover in this class. Again, mostly in this class, we're going to cover the hyperbola features algebraically and how they're connected to the basic equation of a hyperbola, that is the standard equation for a hyperbola, which is either one of these two, either of these two. So let's go ahead and do an example. Let's find vertices, foci, lengths of the transverse axis and the conjugate axis, distance between foci, asymptotes, and eccentricity if the equation for my hyperbola is x squared over 16 minus y squared over 81 is set equal to 1. If you want to try this on your own, push pause on the video and try this on your own. In a couple seconds, I will show you how it's done. All right, so here we go. X squared over 16 minus y squared over 81 is equal to 1. That means my a squared. A is the one that goes with the positive term. So a squared is 16, which means a is 4. B squared is going to be the 81, which means B is 9. Okay. Now I should say this before I state what my vertices are. Because I have the positive part involving x, I know that my hyperbola is going to be pointing left and right. In other words, my transverse axis is going to be horizontal. Okay, that's all because this x is positive. And the reason I know that is because if I plug in a 4 for my value of x and a 0 for my value of y, I will get 1 is equal to 1. However, if I plug in a 0 as my value for x, then I would get a negative number is equal to positive 1, which can't happen. So if somebody thought this hyperbola was pointing up and down, you'd say, well, that would force me to have a vertex of the form 0, comma, some y value. That can't happen because if I plug in a 0 for x, this goes away and I get negative something is equal to a positive 1, which obviously cannot happen. So I know my hyperbola points left and right. And that tells me something about the vertices. Since A is 4, I know that the vertices, we move from the center, which is our origin, 4 units to the right to get to the point 4, 0, and 4 units to the left to get to the point -4, 0. Length of the transverse axis is double A, so that's 8. Length of the conjugate axis is double B, that is 18. Now, the other two features that I can do with just A and B is I can find the asymptotes. So might as well do that right now. Notice that the B squared is underneath the Y. Slope is change in Y over change in X. That's how I remember this. And so the asymptotes are going to be like 9 over 4. I'm going to have slope 9 over 4 or slope negative 9 over 4. And they go through the origin. So they're going to look like Y equals 9 over 4 times X and Y equals negative 9 over 4 times X. Again, Y, change in Y divided by change in X. So 9 over 4, B over A in this case. And one will be positive 9/4, the other will be negative 9/4. Since they go through the origin, it's just going to be Y equals some slope times X. So that's how we can find the asymptotes. Now I know my vertices, my asymptotes. By the way, it would be pretty easy to draw this by hand now. All we have to really do is find the vertices and the asymptotes, and then it's easy to draw by hand. We don't do much drawing by hand, but that's why these things are important. One of the reasons. Now let's look at the foci, or let's find the foci. C squared is A squared plus B squared for hyperbolas. Again, be very careful that you don't mix up the hyperbola C with the ellipse C. For hyperbolas, C squared is A squared plus B squared. For ellipses, it's A squared minus B squared. So don't mix those up. In this case, we have A squared is 16, B squared is 81. So if you take 16 and add 81, that's 97. So C is going to be the square root of 97. To get to the foci, we have to go beyond the transverse axis, beyond the vertices. So we're moving in the X direction. So the two foci are going to be the square root of 97, comma, 0, and negative square root of 97, comma, 0. The distance between the two foci is basically twice the C. So all we have to do is do 2 times the square root of 97. And then the eccentricity is always C over A. In this case, we get the square root of 97 all divided by 4. Remember, A here is 4. Square root of 97 divided by 4 is about 2.46. Notice that this eccentricity is more than 1. And you can convince yourself that that's always going to be the way because since C squared is equal to A squared plus B squared, C is always going to be bigger than A. So this fraction is always going to have a numerator larger than the denominator. Therefore, the fraction is always going to be bigger than 1. And in this case, we get 2.46 as the eccentricity. So on a hyperbola, eccentricity is always bigger than 1. But that's it. That's the idea there. I started with an equation. I came up with all of the features that were listed about the hyperbola. Now, I've taken the time just to graph that out on Desmos. You can see the two vertices here, -4, 0 and +4, 0. And then you can also see the two foci, which are right here. So those are the two foci. Square root of 97 is about 9.84. So there you go. Also, if you want to look at the asymptotes, the one with positive slope has positive slope of 9/4 going through the origin. So y equals 9/4 times x. The one with negative slope is y equals -9/4 times x. And so you can see as you get further and further out, these two parts of the hyperbola look like they're approaching those two lines. But there you go. That's what this hyperbola looks like. Let's try another example. Let's take a look at this hyperbola and find the features of it. We have y squared over 25 minus x squared over 9 is set equal to 1. Push pause on the video and try to find the features of this hyperbola using the equation. In a couple of seconds, I'll show you how it's done. All right, so this is the standard form for the hyperbola centered at the origin. And in this case, the a, again, that's always the one under the positive part, is 5 because a squared is 25. So a squared is the one underneath the positive part. That's 25, so a is 5. B squared is going to be 9, so b here is 3. Moreover, since the y squared is the positive component, I know I'm calling that the positive component for obvious reasons. There's a negative sign in front of the negative x squared over 9. That means this hyperbola is going to point up and down. In other words, if I put a 0 as my x value and I put a 5 as the y value, I can get to a vertex. I can make that equation true. Same thing if I put a 0 as my x value and -5 as the y value. So there we go. That means the vertices are going to, again, move up and down. So we go 0, 5, and 0, -5. Length of the transverse axis, since A is 5, length is 10. Length of the conjugate axis, since B is 3, length of the conjugate axis is 6. With a hyperbola, C is calculated by taking C squared and setting it equal to A squared plus B squared for the hyperbola. A squared plus B squared is C squared. In this case, that's 25 plus 9. 25 plus 9 is 34. So C is the square root of 34. Not a lot of nice simplifications there. Because we're pointing up and down, my foci are going to move vertically. So the foci are going to be at 0, comma, the square root of 34. And then also at 0, comma, the negative square root of 34. Distance between the foci is double that, so 2 times the square root of 34. And then eccentricity is C over A, so that's square root of 34 divided by 5. And By the way, once again, taking square root of 34, dividing by 5, you get a number that is above 1, specifically about 1.17. Now, the last thing I was going to do is do asymptotes. Um, Slope is always change in y over change in x, so I think of that as the number underneath the y, which in this case is the a. So we're going to go 5 over 3. So 5 over 3 is one slope, and negative 5 over 3 is another slope. Since they both go through the origin, both asymptotes go through the origin, it's going to be y equals 5/3 x as one asymptote, and y equals negative 5/3 x as the other asymptote. So there we go. That hyperbola has these features. Let's go ahead. I'll graph it quickly and show you that we did get the correct graph. So here's the graph of that hyperbola. And we can see via the graph the features on it. And sure enough, it goes through 0, 5, 0, negative 5. If you graph the two asymptotes, this is what they look like. You can scroll out and see that they do give you the correct asymptotes. And then if you wanted to graph all of the points that we found, like the vertices and the two foci, then that's where they are. Notice that in this case, we had a little bit stronger bend in our hyperbola, and the focus and this vertex, the closest vertex, were pretty close to each other. In our previous example, our focus and our vertex were a little bit further away on each side. And so the bend was not quite as sharp. Here's another example to try. Let's find the equation and the features of the hyperbola graphed below. And here we're going to say that the highlighted point is the point 6, comma, root 98. Now I want to start out by just making some observations. First off, we can see that this parabola is, or excuse me, this hyperbola is pointing up and down. So the hyperbola is pointing up and down, and it's centered at the origin. If you move up 7 units and down 7 units, you hit a vertex. So those are the important features here to get us started. And then we have a point on the hyperbola that is given to us. All right, since we're pointing up and down, the y squared component is going to be the positive component, and the negative component is going to be the one with the x squared. So the general form of the equation is going to be y squared over a squared minus x squared over b squared is equal to 1. And since we see that this hyperbola goes through the vertex of 0, 7 and the other vertex of 0, negative 7, we know that a is going to be 7. So we scroll down and write that a is 7, a squared has to be 49. So the form of the equation is going to be y squared over 49 minus x squared over b squared is equal to 1. Again, we see that it's centered at the origin, so I know I have that as my standard form of the equation. In fact, let me just write that equations there. All right, now I've seen my vertices. So my vertices of this hyperbola, 0, 7, and 0, -7. That means the length of the transverse axis is 14. Don't yet know the length of the conjugate axis because I don't yet know B. I can't find the C value because I don't yet know B either. And then all of these other things require me either to have C or B. So since I don't know B yet, I don't know anything else yet. This is where the highlighted point comes into play. The highlighted point is the point 6 square root of 98. So what I'm going to do is off to the side or on some scratch paper, I'm going to plug in 6 for x and the square root of 98 for y. Now I know that that's going to give me a true statement because that point is on the graph. So that has to give me a true statement when I plug it into my equation. And now I have an equation where the only variable that I need to find is b. The only variable in my equation is b, so I can find that variable. When I square the square root of 98, I just get 98. 98 over 49 is going to be 2. When I square 6, I get 36. So what I end up with is 2 minus 36 over b squared is equal to 1. I can add, let's say I add 36 over b squared to both sides and then subtract 1 from both sides. That would give me 1 is equal to a positive 36 over b squared. I'm going to think of that 1 like a 1 over 1, and then I'm going to cross multiply. So 1 times b squared is going to be equal to 36. It's not always the case that it comes out so nicely, but in this case, it came out very nicely. And so b squared is 36. That means b is 6. And now I can go back up and put all of that in my equation. B squared is 36. So this is the equation that I end up with. We already have the vertices. We already have the length of the transverse axis. The length of the conjugate axis is double B, so that's 12 in this case. And then in order to find the C squared is equal to A squared plus B squared on a hyperbola. In this case, that's 49 plus 36, and 49 plus 36 is equal to 85. So C is going to be the square root of 85. That means the two foci are the positive square root. Oh, I'm sorry. No, we have to go up and down, don't we? Because we're pointing up and down. So I have to go, 0, comma, the square root of 85. And then 0, comma, the negative square root of 85. So there we go. That's where the two foci are. The distance between the two foci is just double the square root of 85. The eccentricity is the fraction. C is the square root of 85 divided by A, which is 7. If I take the square root of 85 and then divide that by 7, I get about a 1.32. Once again, the hyperbola has eccentricity that is above 1. Now, the last thing I'll do is look for asymptotes. Again, change in y over change in x is the way I think of it. So the number underneath the y is an a in this case. So we get 7 over 6. As the slope, asymptote will be y is equal to 7 over 6 times x. The other asymptote will be y is equal to negative 7 over 6 times x. I may have mentioned this before, but some slopes will be more than 1 or less than 1. It really can be any numbers here. On all of the ones that we've done so far, the slopes have always been in positive terms bigger than 1, but that's not always the case. But there you go. The key thing there is to find the B. We have this tool where we can plug in a point. Plugging in a point and solving for B can be used to find the B. So that's how we could find the equation and the features of a hyperbola if I see the graph and I can tell what one point on the graph is. Here's another example that we can do. We're going to find the distance between the foci of the hyperbola if I just know the transverse axis and the conjugate axis lengths. Go ahead and push pause on the video and try this on your own if you'd like. In a couple of seconds, I will show you how it's done. All right, the key thing here is that the transverse axis is length 2a. So if a is the a from the equation, we end up with the a value being 5. And in a similar sense, the b value would have been 8 here. So conjugate axis has length double the b value. So 16 is double 8. And the transverse axis has length double the a value. So a is 5. Now, we aren't asked to find the equation for this. And that's kind of good because this doesn't tell us if we're centered at the origin or not. It doesn't tell us whether our hyperbola is pointing up and down versus left and right. But it's only asking for the distance between the foci. I can find that in this example by utilizing the formula for C in a hyperbola. In a hyperbola, C is calculated by letting C squared equals A squared plus B squared. In this case, we know the A squared is going to be 25. We know the B squared is going to be 64. So I'd take 25 plus 64, and that would give me an 89. Now, 89 obviously is not a perfect square. So C is the square root of 89. And that means the distance between the foci is double the square root of 89. So there you go. Distance from the center to one focus is square root of 89. Distance from the center to the other focus is square root of 89. So from focus to focus, the distance will be twice the square root of 89. So there you go. We don't even have to find an equation in order to solve this problem. We just need to figure out what the A and B are and then use the formula for finding C in a hyperbola. Let's try another example. This asks us to find the equation and the features of the hyperbola if the center of the hyperbola is at the origin, the conjugate axis of the hyperbola is along the x-axis and has length of 14, and the transverse axis has length of 32. Go ahead and push pause on the video. Try this on your own if you'd like. In a couple of seconds, I'll show you how it's done. All right, so now I'm ready to do this. First off, we're centering this at the origin. So we know our equation is going to look like one of two options. Either y squared over a squared minus x squared over b squared is equal to 1, or I reverse the roles of x and y. In this case, it says the conjugate axis is along the x-axis. That means the transverse axis is along the y-axis if the center is at the origin. So the transverse axis is going up and down. Remember, at the end of the transverse axis is where our two vertices are. And so this hyperbola is going to be pointing up and down. Which means the equation that we're going to get is going to have y component, which is the positive component, and the x component of the equation is going to be the negative component of the equation. Y squared over a squared minus x squared over b squared is equal to 1. Now the conjugate axis has length 14. That means b is 7. And that would also mean b squared is 49. The transverse axis has length 32. That means a would be equal to 16. A squared would be 256. 16 squared is 256. So that gives me my equation. Y squared over 256 minus x squared divided by 49 is equal to 1. That's the standard form for this hyperbola. Now the vertices we get by moving up and down. So my vertices are going to be 0, 16 and 0, negative 16. Length of the transverse axis, it already told me that, but we could have also figured it out by just doubling A. Length of the conjugate axis, it already told me that. We could find that by doubling B. So length of the transverse is 32 again. Length of the conjugate is 14. C squared is equal to A squared plus B squared in a hyperbola. The A squared this time is 256. The B squared this time is 49. 256 plus 49 is 305. That's not a perfect square. So C is equal to the square root of 305. Again, the foci are beyond the transverse axis, so we're going to go a little bit up and a little bit down. So the foci are at 0, comma, the square root of 305, and 0, comma, the negative square root of 305. Distance between the two foci is 2 times the square root of 305. Square root of 305, I don't think simplifies very nicely, but it may. I don't think it does. So C over A is the eccentricity. That's the square root of 305 divided by A, which is 16. Once again, you can see that that is just a little bit over 1, about 1.09. Lastly, the asymptotes for this hyperbola. I always think of change in y over change in x. So I look at the number underneath the y. 16 is the a. Then I look at the number underneath the x. That's a 7. So the slope is going to be 16 over 7 and negative 16 over 7. So the two asymptotes are y is equal to 16 over 7 times x, and y is equal to negative 16 over 7 times x. And that gives me the equation and all of the features for this hyperbola. The hyperbola whose center is at the origin, whose conjugate axis is along the x-axis of length 14, and whose transverse axis has length 32. Let's do one more example where we find the equation and the features of a hyperbola. In this case, my hyperbola is centered at the origin. We're going to have a vertex at negative 4, 0 and a focus at negative 7, 0. Go ahead and push pause on the video and try this on your own if you'd like, and then I will show you how it's done. All right, if the center is at the origin and the vertex is at negative 4, 0, and the focus is at negative 7, 0, then my hyperbola is pointing left and right. So the equation of my hyperbola is going to have the form of x squared over a squared plus y squared over b squared. Excuse me, minus, did I say plus? Excuse me. Minus y squared over b squared is equal to 1. Sometimes when I'm doing conic sections, it's really easy to flip a minus or a plus sign. Think about ellipses to hyperbolas and parabolas and hyperbolas and get a little bit tongue-tied. But anyways, hyperbola pointing left and right is going to have positive x component. All right. Now, the vertex is at negative 4, 0. This means from the center, we had to move 4 units to the left. So my a is going to be 4, and my a squared is going to be 16. So I know that my equation is going to look like x squared over 16 minus y squared over b squared is equal to 1. Now I don't know the b squared, and the focus is a point, but it's not on the hyperbola. It's in the interior of the hyperbola. Oh, by the way, since we're here, since A is 4, the vertices are -4, 0, and the other one would have to be +4, 0 if this is centered at the origin. Length of the transverse axis, therefore, is 8. Now, the thing I don't know yet is the B, but I do know where A focus is at. A focus is at the point -7, 0. That means the other focus, if we're centered at the origin, is at the point +7, 0, which means the value of C is going to be 7. Now I know the value for A is 4 and the value for C is 7. So I can take this equation, the equation that I usually find C for the hyperbola n, and I can say that is going to be 49 is equal to A squared is 4 squared, which is 16, plus B squared. And I can solve that for B. So 49 minus 16 is 33. 33, therefore, is B squared. So I'll write that up here. B squared is 33. B would be the square root of 33. So the length of the conjugate axis is double the square root of 33. My equation, now I know what my equation is exactly. X squared over 16 minus y squared over 33 is equal to 1. Be careful not to square that 33. By the way, the distance between the two foci is a 14. That's double 7. Eccentricity, which is C over A. Well, that C was a 7, A was a 4, so the eccentricity is 7/4, which is 1.75. The asymptotes, well, I always think of it as change in y over change in x. So the number underneath the y squared is going to be on the top. The number underneath the x squared is going to be on the bottom. Therefore, we get square root of 33 over 4 as the slope. So asymptotes are going to be y equals square root of 33 divided all by 4 times x, and y equals negative square root of 33 divided by 4 times x. So those are all of the features that we find on a hyperbola. In this case, I was given a vertex, a focus, and the center of a hyperbola, and I could come up with the equation and all the other features based on those 3 things. Hopefully that all makes sense. So that's the idea of how we can take these standard forms of the equations for hyperbolas and find the features of those hyperbolas, and then go the other way as well. If I'm given a few features of the hyperbola, I should be able to find the standard form of the equation. So there we go. That's the end of this video.